Okay, so I went ahead and wrote out all the important information for this problem. The 2.11 grams of aluminum nitrate combined with the 2.56 grams of sodium carbonate, which produced 0.0771 grams of precipitate. So first, to start out this equation, I'm going to write out the equation, which is going to be aluminum, then it's NO3 for aluminum nitrate, and then plus, we're going to leave a gap when we start balancing this equation, Na2 plus CrO4, and then it'll be going to make our product, which is Al2 plus, or not plus, but just the rest of it is CrO4 and then plus it's going to be Na with NO3. But now we can balance the equation. NO3 is already balanced, but actually first we have to write 3 for NO3 because Al has a plus 3 charge, so NO3 is already balanced, so we don't need to change that, but the second half of the equation has 2 aluminum, and the first half only has 3, or the second half has 6, and the first half only has 3, but we can fix that very easily by adding a 2. Oh, you can't even see the 2. Okay, let me just, there we go, 2 Al to make it 6 aluminum, but the CrO4 is still unbalanced. We have 3 on the right side and only 1 on the left side, so we fixed that. But now we need to balance the Na and the NO3 because we actually changed the NO3, but we have 6 Na on the left side, and so we just write the 6 in front here because we also have 6 NO3. Okay, now that we have the equation written out, we can write out the molar mass of every precipitate we have. So aluminum nitrate has a molar mass of 213.0 grams per mole. Then we're gonna move on to our sodium carbonate, and our sodium carbonate had a molar mass of 161.97 grams per mole. Okay, and now we know what our precipitate is. It's gonna be aluminum chromate. And the molar mass of aluminum chromate is 437.99 grams per mole. Okay, now that we have all our information written out, we can start finding the theoretical yield. But yes, we can start finding theoretical yield now. Okay, so next we're gonna set up the equation for moles of reactants. Oh, it's supposed to be in red. So aluminum nitrate. And you're gonna put the grams, the mass on top, 2.11 grams over the 213.01 grams and per moles, and equals point oh oh 9 moles. Now I can set up the one for the sodium chromate. Which is still going to be the mass on top and the molar mass on bottom. And when we calculate that, it's going to be 0.016 moles, because the moles, or the grams, cancel out on bottom and top. But before we can move on, we need our mole ratio, which is 2 to 3. And that's because if we come up here, we have 2 aluminum nitrate and 3 sodium chromate. Okay? So, now we can do our multiplication with 0.009 moles times our 2 moles or 3 moles of sodium chromate over our 2 moles of aluminum nitrate. And when we multiply that out, we're going to get an answer of 0.015 if we're following our rules for significant figures. Oh, moles. 0.015 moles. And then we're going to do this again with our aluminum nitrate. This time our mole ratio is going to be 1 to 2. So we can go ahead and write our new mole ratio, which is 1 to 2. And now we can start our next equation. So we're going to write 0.009 moles times our mole ratio, which is going to be our 1 mole of aluminum nitrate on top, or not aluminum nitrate, aluminum chromate. And then we're going to do our 2 moles of aluminum nitrate underneath. Okay. Then when we multiply this out, we get 0.005 moles, because we're using our significant figure rules. So 0.005 moles times our mass of aluminum chromate, our product. And whenever we multiply that out, we're going to get our theoretical yield, which is going to be 2.17 grams. To find our percent yield, we're going to do the actual yield over the theoretical yield. Times 100% to turn it into a percentage. And we just found our theoretical yield. And we don't actually have to find the actual yield because the actual yield was given. It's our precipitate, 0.0771 grams. Right here. Okay. So we're going to put our actual yield over our theoretical yield. And multiply by 100%. And first, whenever we do the division, we're going to get 0.3552. But when we multiply that by 100%, it turns to 35.52%. And that's going to be our percent yield. And I actually just did this whole problem in the wrong color, but that's okay. Okay? So, we can now do the last part of our problem. We can record the excess reactant, which is actually pretty simple. So we're going to write out our initial, which is going to be 0.015 moles of Na2CO4, and our final, which is 0.016. And then all we have to do with these two is subtract the initial from the final amount. And 0.016 minus 0.015 is going to be 0.011 moles. And I actually should have been writing moles right here. So now I have to multiply our moles by the number of the initial mass, molar mass. Then we're going to multiply that out to get our answer of 0.0153 grams of excess reactant. And that's the whole problem.